Hi, so in this video what we're going to do is we're going to find the determinant of a matrix, and we're going to do so by hand, and then we're going to verify with technology. Now, finding the determinant of a matrix by hand is very similar to finding reduced row echelon form by hand. There's a number of ways you can go about doing it and a number of allowable operations. So just as a brief recap of what we're allowed to do, you can swap rows or swap columns, and that'll change the sign of the derivative. You can scale a row, and that will scale the derivative by that amount. Or you can take a 1 in the diagonal where either the row that it belongs to, or the row that it belongs to, or the column that it belongs to is otherwise all zeros, and you can take out that row and take out that column and reduce the size of your matrix. So we're going to utilize that as our main tool and try to reduce this matrix down to be a 2 by 2 matrix, which is a standard determinant. And so what I'm looking at is here, I already have in this bottom right a 1 in the diagonal. And so that not only puts it in a perfect position to be canceled out, it also makes it easy to turn this column into a 0 column. And so what I'm going to do now is I'm going to take minus 2 times this last row and add it to the second row, minus 5 times this last row and add it to the first row, and with your permission, I'm going to do it all in the same step. So let's see what that's going to look like. That's going to be equal to determinant, and the bottom here is going to be unchanged. And I'm not going to do anything to the second to the last row, so that's unchanged as well. And now note that as I add copies of these rows to these two rows, since these are both 0 here, none of this stuff up here is going to change. So why don't I go ahead and verify that that's all going to be the same, and now let me go about the business of canceling out the rest of this stuff here. So first thing to note, minus 1 times, or minus 2 times 1 plus 2 is 0. So that's a 0 there, which is what I was going for. But I also get a 0 here, right? Minus 1 times minus 2 is positive 2, plus minus 2 is 0. And then 1 times minus 5 will give me a 0 here. And then minus 1 times minus 5 is positive 5, plus the 1 gives me a 6 here, right? So that is... and remember, both of those moves, taking copies of a row and adding it to another row, don't change the determinant. So this is a for real equality. And then what I'm allowed to do at this stage is get rid of that, right? And so that leaves me with the determinant of 5 minus 4 is 6, minus 2 minus 3 is 0, 3, 4, minus 3. And then now it's not as clear what I should be doing, right, to try to find this determinant. But what I do know is that if I took this last row, say, maybe, and added to this row, that'll put a 1 there. And then that'll put that on the diagonal, which will leave it in a perfect position for me to try to 0 out that column now. So this determinant is going to be equal to the determinant of what happens if I add a 1 there. My last row is unchanged. My first row is unchanged. And then what I get is 1, 1, minus 3. So far so good. And then what I want now is to kill that and kill that. And I can do that by taking 4 times the second row, adding to the top row, minus 4 times the second row, adding to the bottom row. So why don't we go ahead and do all of those in one step. And again, remember that no step we've taken so far changes the determinant. So 4 times the middle row plus the top row will give me 9, 0, minus 12 plus 6 is minus 6. And then I have 1, 1, minus 3. And then minus 4 times 1. Sorry, this is a... No, that's right. Minus 4 times 1 plus 3 is minus 1, 0. And then, okay, positive 12 plus minus 3 is positive 9. Zip zap. And now we have a sort of standard determinant. Is the determinant of 9 minus 6 minus 1, 9, which if you recall, we can just take these diagonals and that will give me 81 minus 1 minus 1 times minus 6, sorry, which is 81 minus 6, which is 75. Alright. So that was the process of finding this determinant by hand. And then if we check our favorite ways of computing things by hand, first I have my Sage cell here. I put the matrix in, I had it show its determinant, and it's 75. And we also have the Desmos matrix calculator. We have the matrix here. I validate the determinant. That's 75 as well. So both of those give you the 75 that one would hope for. Alright. Thank you very much. I'll see you in the next video.